Here we go. Might be the final one, we'll see. Number 24 says the following equation is a circle. You might look at this and go, hey, it's an ellipse. Well, you're right, it's a perfect ellipse, which is called a circle. Why do I know that? Because these are the same. So change one thing to make it the equation of an ellipse. Let's start there. Remember, there's a few things you could change. All I'm going to do is change one of these denominators. Make that like a 25. And then how do you make it a hyperbola? Well, you know, to change one thing kind of limits it. Now, the one thing we can change then is the subtraction, because that has to change. Now you guys might say, well, wait a minute, that's a circle. No, that's a minus. Circles don't have minuses. So there we go. Now this next section, I really don't know how much time to spend on it. This 2022-23 year, we may not even get to this statistics because of a big snowstorm, but all the residents I'm going to teach this as fast as I can. In an apartment complex in Rockford, so they're not trying to figure out about the apartment complex, they're trying to figure out stuff about the city of Rockford, were polled about who they would vote for in an upcoming presidential election. Which of the following would be considered a sample and a population? Now the population is, who are they trying to figure out? Well, that would be Rockford. So look at the population, the registered voters in Rockford. It's not the apartment complex, so it's looking like B is good. What's the sample? The residents of the apartment complex, because that's who was polled. So you can read through the rest of them to see why they're wrong. I'm just not going to take the time to do that. So number 26, which of the following is an example of a categorical variable? Remember, the key to that is there's no number values. So the weight, that has a number. Proportion, that's a number. The number, the brand. So keep that in mind with your vocab. Next problem, number 27. Analyze the following data sets. Determine if they are skewed left, skewed right, or symmetrical. Now I'm not going to waste up this time drawing all this. I'm going to be back in 2 seconds. Okay, so I looked at my data. I could see I could chunk it off into chunks of 5. And then how many numbers are between 10 and 15? There was 2, so I went up to 2. Between 15 and 20, there was 1, 16. And I did the same thing for all these values in these sets. And if I drew this little line, you could see, because it tapers off to the left, this is skewed left. Alfonso watches the patrons at Meijer. Watches. That's a key right there. And counts how many pay for their groceries with cash and how many use a card. What type of study? Not an experiment, not a sample, not a cluster. He is observing. All right. So I'm just going to do one of these instead of 2 just to save time. What's the mean? Well, that's the average. Let's talk about that. 12 plus 3 is 15. 15 plus 15 is 30. 52, 58, 70, 82, 89, and wouldn't you know it, we got 100. We got to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I take my calculator and I go 100 divided by 9, I get 11.11 repeating. There's my mean. What's the median? Well, the median requires that I take these numbers lowest to highest. 3, took care of that one. 3, took care of that one. Next highest is 7, took care of that one. There's 3 12s. 1, 2, 3. Ooh, need to sneak an 11 in there. And a 15 and a 22. I wish I wouldn't have screwed up that 11, but we'll make sense of it. So the median, if we count the number of things we have, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's nice because we have an odd number of them. You would just find whatever number's just comfortable in the middle. Zoom in here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there's our middle median number, 12. Mode is the number that shows up the most. That's clearly a 12. Okay. All right. So number 30 is how to calculate the standard deviation. So this symbol stands for standard deviation. This is the sum of all of this. Now what is this? Well, x is the set of numbers. So we have to go through this process, the number minus the mean squared, for every single number. So clearly we got to find the mean. So 28 plus 7 is 35, 38, 47, 56, 60 divided by 1, 2, 3, 4, 5, 6, 7. Maybe I should have made these numbers a little easier for this problem, but 60 divided by 7, 8.57. So we have to take each number, 12. You know what? I'm going to change these numbers. There we go, a little trick by a math teacher. Instead of making that a 4, I'm going to make it a 7. And if I add this, plus this, plus this, plus this, this, and the 7, I'd get 63 divided by 7, which would give me a nice tidy 9. So that's our mean, 9. So we have to stick it in here each time. So 12 minus 9 squared is 3 squared, which is 9. 16 minus 9 squared is 49. 7 minus 9 squared is 4. 3 minus 9 squared is 36. 9 minus 9 squared, that's a nice one, is 0, because we have to do it again. It's a nice one. And then 7 minus 9 squared gives us our 4. Now we got to add all these up. That's what this symbol means. And here we go. 58, 62, 98, 102. All right. So that turns into the big old square root of 102 all over. N stands for the size of the set. 1, 2, 3, 4, 5, 6, 7 numbers. So we got to get handy dandy with our calculator. 102 divided by 7. Enter. So now we're going to take the square root of that. And 14.57. So 14.57. So our standard deviation, I'm going to just go SD, is approximately 3.82. All right. There's how you calculate standard deviation. All right. Back to more of your straightforward Algebra 2. How do you square a binomial? Well, you don't square these individually. You go 5 plus the square root of x, 5 plus the square root of x. So first, 25. Outside, 5 square root of x. Inside, 5 square root of x. And then last, the square root of x times the square root of x, the roots fly off. So what do I end up with? I end up with x. Well, I could go 25 plus 10 square root of x plus x. You could rearrange those any way you want. How do you simplify this? Well, the first thing I'm going to do is ignore the negative, which is dangerous because that means I have to remember it. Now this right here is actually saying find the fourth root of 16, which I know is 2. Now I have to cube it, which is 8. But now I got to remember there was a negative there, which means I got to put it where it ain't. Reciprocal. Choose all the answers that are considered real. Well, first of all, that's an odd index, which means it's okay to have a negative there. It's not saying find the answers, but if you did find the answer to this, it'd be negative 2, because negative 2 cubed is negative 8. So this is a real number. Now this is a tricky one. I'm going to go to this one first, because this is like a PEMDAS. Negative 3 squared would be 9, and the square root of 9 is real. This problem is actually not squaring the negative, but it sure is tricky. It's the same thing as this, which is the same thing as this, which the square root of negative 4 is not real. This is tricky, because if you just looked at the negative and saw that that was an even index, you'd go, oh, that's real, or that's not real. But remember, you got to look at this first, and that'd be a negative 3 times a negative 3 times a negative 3 times a negative 3, 4 times, which I don't care about the answer on this problem. I want to know this is the fourth root of something positive. Guess what that makes it? Makes it real. All right, simplify. Square root of 18, that breaks down into 9 and 2. Square root of 9 is just 3. Whoops, I put a plus, plus a minus. 50 turns into 25 and 2. So this is 3. 3 times 3 is 9 square root of 2 plus 3 minus 5 square root of 2. Well, these are like terms, so I'd get 4 square root of 2 plus 3. Cubic roots. Well, the cubic root of 8 is just straight up 2 minus cubic root of 54 is the cubic root of 27, which is a perfect cubic root, times 2. I'm just going to keep going down the line. Plus 2 times the cubic root of 125. That's the largest perfect cubic root that goes into 250 twice. All right. Remember, our list of perfect cubic roots that you need to be comfortable generating, either literally like I did or mentally, are right there. So what is this? That's 3. So I get 2 minus 3 cubic root of 2 plus, now what is the cubic root of 125? Well, that's 5. 5 times 2 is 10 cubic root of 2. We got some like terms here. So that would be 2 plus 7 cubic root of 2. There you have it. 35. Are the following graphs increasing or decreasing or both? Remember, left to right. So, if my roller coaster starts out on the far left, remember it's left, so start out as far left as you can. I'd be going down and then I'd be going up. So that's both. What about this one? Well, there's my roller coaster, and this would be going down, 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 down. It is getting smaller and smaller as you go, so it's decreasing. Okay, just a straight up question based on your a times b to the x lesson on exponential growth or decay. It has everything to do with the letter b. You can ignore that. This right here. Ooh, this is a little trickier than I thought. Hold the phone. Hold the phone. So if we actually took a look at this, the parent function, and looked at it, and we thought, okay, think of y equals 2 times 3 to the x. This one almost got me, so I'm in a hurry. This right here, generically speaking, would look like this. Now, the thing about it is, we would have to reflect this. Give me 1 second. Yeah, this one almost got me. Tricky little math problem. But remember, this looks like this. That, by rule, reflects it over the x-axis. So everything would go like this, and you sneakily have a decay problem. Interesting. All right. How many minutes do we have here? 13. Okay. I don't think I'll get done, but you never know. Evaluate. Well, that just means solve, because there's a little mystery x there. So 4 to some power is 1/16. And you could look at this and answer it, or go by the way I've been teaching it, common bases, happy places, because I'm going to change that 16 to 4 squared, then I'm going to bring it up. So 4 to the x equals 4 to the negative 2. These cancel. So x equals negative 2. Solve this. Well, this is the problem where I said, brr, common bases, happy places. No way. All right. So now we've got to slap some logs on there. So log of 11, 1.04. And then we're going to take the log of 4.3. Where'd it go? Okay, 4.3. And then so we have, but the first thing I'm going to do is bring that in the front, because you can and you should. So it's x times, then I looked up log of 4.3 is 0.633. So now I have to divide by 0.633, divide by 0.633. So 1.04 divided by 0.633, 1.6, approximately 1.64. Now we got the letter E. So we're going to slap lateral nogs on there. I'm going to bring that in the front. And remember, what's the natural log of E? 1. So I get 2x plus 1 times 1, which is just nothing. And then I take the natural log of 25, and that's approximately 3.2. So this turns into 2x plus 1 equals 3.2. I'm going to subtract 1, so I get 2x equals 2.2. Divide by 2, and I get 1.1 for x. All right, number 40. I better stop that right now.